Hello everybody, today we're here to discuss and analyze the hybrid orbitals of carbon monoxide. First thing, let's write carbon monoxide, that'll be CO. Let's find the valence electrons, that'll be 4 from carbon and 6 from oxygen, that will give you 10. Now we have to find the correct Lewis structure. So that one would be, so with the simple one, CO, we need 10, so let's add 2 here, and let's add 6 here. And now let's calculate this. That will be carbon is equal to 4, 2, loose electrons minus 1 bond. That will give you 3. And now we go to this, right? So that gives you 3. So this one is 3 plus. Now we go to oxygen. That will be 6 minus that's 2 bars electrons minus 1 bond minus 6 loose electrons. That gives you negative 1, so this is negative 1. So we need to make this more proper. So how do we do that? We take electrons from the oxygen, never from the central atom. So C double bond O. So we got to C here. C will be 4 minus 2 bonds minus 2 electrons. That will give you 0. And oxygen will be 6 minus 2 bonds minus 4 electrons. That will give you 0. Let's do another one, okay? Just to check. 1, 2, 3. I don't like these lines. Let me fix it. 1, 2, 3. Oxygen. 1, 2. 1, 2. So this one will be C is equal to 4 minus 3 pairs, 2 electrons. That would give you negative 1. Oxygen will be 6 minus 2 electrons minus 3 bonds. That'll be 1. Okay, even that this looks the most correct one because we minimize the charges, this one is the proper one due to the fact that we C follows the octet rule, and because if I remember correctly, okay, yeah, it's because C follows the octet rule, so that means that this is the most proper lowest structure. Now we have to find the orbitals. That is the funny part. So let's just redraw this for a second. C, 2 points, 2 points. So so on a single bond we have the q orbitals. It's not q, it's sigma orbitals. Yes, I think it's called sigma orbitals. And on double bonds we got or pi orbitals because they're in the top. So how this will look on a proper Lewis structure? It will be something like this. Oh man, already. Oh no, no, that one is good. trying really hard to draw this. Give me a second. Okay. Mm, okay, that one looks pretty good. Okay, let's continue with this. So let's. I don't like how this looking. Let me think if I can find a better way how to write this thing. So okay, let's try to draw like mm, how maybe there is a tool here that could help us. Oh wait, oh wait, oh this look good. Maybe I could copy this. No, no, not this. So let's copy that one. No, no, keep it dark. Let's create an orbital like this. Oh, actually, this look pretty decent. An orbital like this. Let's move it here. Okay, now we need another one that it should be like okay, like that. Again, I am not pretty good at drawing p orbitals, pi orbitals. So this one, let's say that it would be, I don't know. Mm, let's say this one will be carbon, and this is. Let's copy this, paste it, and like this. Now we replace this one by the oxygen. Okay, so here is our sigma bond. But we also have, if I remember correctly, pi bonds between this and this. And you may ask, why are these called pi bonds? I truly don't know why, but remember if they are farther than the axis, if the bond doesn't occur on the axis, they are called pi bonds. So you got a pi bond over here and a pi bond over here. That was double bonded. So now we have to write the beautiful structure that I forgot her name. But I know it looks like this. Wait, let me use just lines. It's gonna look better if I just use lines. So bam, 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 bam. Okay, so we got 10 valence electrons, so we start like up, down, up, down. Then we go up, up, down, down. So we got 8 electrons over here. We need 10. So we go up and then down. So this will be Q, Q star, pi X, pi Y, if I remember correctly. and by C.
Like I never see what
Or
people
in other
try in
words,
Dragon Ball.
S1
It was good and all.
to S
It's an S.
to PX to PY and
I'm
to
going blue.
PC. Okay, so this would
Try
be
again.
or
I mean,
or
I did
orbit
watch Super.
hybridization for these two. But if we're taking a step further, we can find the number of bonds that this should have, and that is really easy. That is bonds is equal to the number of the levels without the star, the
I hate
electrons
that.
without the star.
Yeah.
That would be 1, 2, 3, 4, 5, 6. That would be 8.
Who reset it, me, bro? What piss me?
Hmm.
Why are you taking my thing off? Why? Why?
And then minus the electron with the star.
You
That
taking
would
my
be this one here. That would be
you take
2
my workshop
all over
automatically.
2. That will give you a number
My workshop.
3. That means you have
You
a
see my workshop on my
triple
PS4, bro.
bond
Why?
just like the one that we have here.
I didn't reset that one.
Also, we can also find if this is paramagnetic or diamagnetic. And how do we do this? So,
Book?
paramagnetic means that you
Do
have
you have
an
electric?
unpaired electron on this structure. We don't got none. So I mean ours is
Like,
diamagnetic
yo, Vegeta's like Loki so lame.
because all the electrons are pairs. If we had like an example like this,
If Vegeta's whole character was
we would have
made better than
that would have
Goku,
been
like,
paramagnetic because this electron is unpaired. But because
and the Starkey
this
has the
electron is
potential.
paired, we got that is diamagnetic. And that is what is we kind of use the Lewis structure to determine if
Exactly.
a
Potential.
molecule is diamagnetic or paramagnetic
Exactly.
because it doesn't tell you pretty good.
Exactly. Potential.
That's
It
why if
has good
you want to find
potential.
out
That's
that
the
you have to
thing.
find first how many pi orbitals, how many sigma orbitals, sorry pi bonds and sigma bonds, and you try this electron configuration to find this because this will tell you if they are pair or non-pair electrons. And if you want to corroborate
I don't
your
know, bro.
number of
Like,
bonds,
that's what made
just
Vegeta
check with this.
interesting. Like,
It, this always will be right for the number of bonds of homogeneous substances.
and no shit. Not
So
like us calling aliens
8,
aliens. Like,
that would be 1, 2, 3, 4, 5.
you
1,
think that's not racist
1,
to them?
2, 3, 4 times 2 because each level has 2 electrons. 8, and the one with the
They
star
keep
will
calling
be
aliens
2 minus
aliens.
2 divided by 2
That
to
we
give you
hear about.
3. So 3 is triple bonded. Okay? I don't know if I made this too
Like
confusing
everyone
for
in the
everybody, but
it's
I
like
tried to
yo,
explain it as best as I
how
could.
goes everyone in
I
class
am
like
really bad at
it goes
explaining.
fine.
So I would guess see you later. Bye bye.
That